Hi, this is Dr. Bheemalingappa. I heartily welcome to you. In this video, I am going to discuss about conversion of NFA to DFA. What do you mean by NFA? For a given state and an input symbol, if there are more than one outgoing transitions, then we say it is NFA. What is DFA? For a given state and an input symbol, if there is one and only one outgoing transition, then we say it is DFA. First, we look at NFA. Suppose you have a regular expression A or B star ABB. The language described by this expression is 0 or more number of A's or B's of any combinations followed by ABB. So possible strings of this language are of ABB, AABB, BABB, or any combination of A's and B's followed by ABB. That is AB, ABB, BA, ABB, 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 like this. Here, star means 0 or more instances, 0 or more symbols. First of all, this NFA is a phi tuple. NFA is a phi tuple. It is denoted as like this. If I use a short symbol for denotion of this NFA, say M is a phi tuple. What is this phi tuple? Is this capital Q sigma delta start state, a set of final states. The NFA for this expression is this. This is state 1. This is double circle. Here set of states is 1, 2, 3, and 4. Here sigma denotes alphabet. The alphabet consists of the symbols A and B. Here I am going to write about that transition function. First, Q0 here refers to start state, that is 1, and A, that is set of final states which are double circle, it is 4. Now I am going to tell about what is this transition function. Our transition function of this NFA is this delta, that is transition function is Q by sigma. It gives 2 power capital Q, that is set of states. The subsets of this power set of Q, that is 2 power Q. So here states are 1, 2, 3, 4. In the transition table, this final state is marked with star or double. Here 4 is the final state we are known, which is also called accepting state. This is the transition function, that is a q by sigma, q by sigma. Yeah. So here from 1 on A, where we are going to state 1 as well as that is state 2. So 1, 2. 1 on B, we are going to 1 itself. 2 on B, we are going to state 3. 3 on B, we are going to state 4. And no outgoing transitions for the state 4. So this is the transition table of this NFA. This is the transition table of this NFA. I think now you have understood what are these terms in this 5 tuple: set of states, input alphabet, transition function, and then start state, and then set of final states. You may have one or more final states, but you will have only one start state, right? For the same example, this DFA is also of a 5 tuple. DFA is a 5 tuple. If I denote a single letter with subscript, say M1, then what is this? 5 tuple is this set of states, same sigma, transition function, start state, and a set of final states. As I am using the subscript 1 for this DFA, so I can use the same subscript for denoting the terms in this DFA. This is A1. Okay. For the same example, that is, we are known what we are taken, AR B star ABB. We are known what is the language that is denoted by this expression. So any number of A's and B's of any combinations ending with that is ABB. This is the language. So the DFA for this problem is this. This is the state 1. You are known every string must end with ABB, right? So A, B, B. So I'm using the state names as 1, 2, 3, 4. States are encircled, and this is a final state. It must be double circled. This is we are talking about there is DFA. NFA and DFA, they both must accept the same language. So, on A, for this is B, sorry, this is A. So if you look at that, so what is this 5 tuple is this? Same, Q1 is same. You have 4 states, 1, 2, 3, 4. sigma is same, AB. I will come to this transition function later. And here Q1 is what? 1 itself, that is start state. This is the start state. The start state will have a directed unlabeled arrow marking towards that state. That is the start state. So here 1 is a start state, and here final state is, that is 4. And coming to this transition table, you are known what states you have: 1, 2, 3, 4. Input symbols are A, B, 1 on A where you are going 2, 1 on B 1, 2 on A 2 itself, 2 on B 3, 3 on A you are going to state 2, 3 on B you are going to state 4, 4 on A you are going to state 2, 4 on B you are going to state 1. So if you carefully watch the transition table of this NFA and DFA, in a table you have single entries for a given state and an input symbol. For example, for 1A you have the entry as 1, for 1B you have the entry as 1. Like this you will have single states in the transition table. Whereas in the NFA, for a given state and an input symbol, you will have more than one state. For example, for 1A you have 2 states, that is 1, 2 as the entry in the table. So this is what the difference between NFA and DFA. How actually you are going to make a conversion from NFA to a DFA. That is what we are going to discuss now. I hope you got some idea about what is this NFA, what is this DFA. In terms of this transition table also, you can state the difference. And so you came to know the basic difference between this NFA and DFA. Now, directly I have written the DFA corresponding to this NFA. Now I am going to explain how actually you are going to make this conversion. All we are known that drawing this NFA is very much easy when compared to this DFA. Right, for the same NFA, now I am going to show you how to convert NFA to DFA. So the transition function of this NFA is this delta star of QYA is union of R belongs to, let us say, delta star of Q epsilon delta of RA. This is the transition function for NFA. Whereas the transition function for this DFA is this, that is delta star of, here I am using delta 1. So let me state in terms of this, okay, delta 1 itself to avoid confusion. Delta 1 star of Q by A is equals to delta 1 of just a second, delta 1 star of Q, Y, A. One thing you remember, for single input symbol, delta 1 star of Q, single input symbol say A, is equals to delta 1 of Q, A. Don't get confused about this delta 1 star and okay, just delta. The basic difference between these two is this. Delta 1 star is this. Delta 1 is this. Q by sigma gives Q. Delta 1 star in the sense this is Q by sigma star gives, that is Q. And being this is a DFA, you don't find transitions on epsilon. Epsilon is an empty string whose length is of, that is 0. So delta 1 star of Q on epsilon is Q itself. You just make a note of that. So this is what this DFA. Now you are going to look at how to convert this NFA to DFA. For the same example, already you are known the transition table of this NFA, that is ARB star ABB. This is what we have here. So let me take this one itself instead of rewriting it once again. First, whenever you are making a conversion, this is a transition table of what? That is NFA, right? That is delta. This is NFA table, right? This one is NFA table. Now I'm going to, by making use of this table itself, I'm going to make a conversion. At first you are supposed to start with, that is the start state, and you are known that the start state for this NFA is, that is a 1, and your sigma is same. If you look at this 5 tuple representation of this NFA and DFA, no change with respect to this sigma. No change with respect to this sigma. That is the reason at two places I have used same notation, but you can find difference in terms of other terms, right? So now you are known the input symbols are A, B. So 1 on A, you are known, you have, that is 1, 2. From the table itself or from the diagram, we can do this. 1 on B, that is 1, right? And this 1, 2 is a new state. So you have 1, 2 and 1. Already you have defined this transition table for 1. Now this is the new set of state, that is 1, 2. So for that you have to define what is this transition on input symbol A for this new state, that is 1, 2. So 1, 2 on A, that is 1 A union 2 A, that is 1 A is 1, 2. 2A is what? That is a blank. So if you take the union of these two things, what you are going to get, that is 1, 2 itself. I hope you are clear. 1, 2 on B in the sense 1 on B is 1 and then 2 on B is 3. So if you take the union of these, you are going to get it as what? 1, 3. So 1, 2 on B, that is 1B union 2B. You are known 1B is 1, 2B is 3. Therefore you are going to get, that is 1, 3. So 1, 3. And this is a new state, that what you have got, and you need to repeat this process as long as you are getting new set of states. Once you find that you are getting same set of states, then you can stop. So already I have defined for this 1 2. Now I'm going to take this 1 3 1 3. So what is this 1 3? 1 on A, that is from transition table of this NFA how to take. So this is what? DFA, right? This is the symbol for this DFA is delta 1 DFA. You have seen in the notation also. The symbol for this NFA is what? Delta, right? Delta. So 1 3 on A means what? 1A union 3A. So 1A union 1A is 1 2, 3A is nothing. So you are going to get what? That is 1 2 itself. I think you have understood this. And then 1 3 on B is what? 1 on B is 1, 3 on B is 4. Therefore, you are going to get it as what? 1 4. Yeah. Now you have this is a 1 4. This is a new state which was not occurred earlier. Therefore, I need to define the transition for this set. That is 1 4. So 1 4. 1 4 on A is what? 1 4 on A in the sense 1A union 4A. So 1A is 1 2, 4A is nothing. So 1 2 union nothing, you are going to get, that is okay, 1 2 itself. 1 2. Okay. 1 4 on B in the sense what? 1 on B is 1, 4 on B is okay blank. So 1 4 on B is what? What you are going to get, that is okay 1 itself. I think you have understood. So this is delta 1, this is okay delta. So what? So delta 1 of, I can state right in this fashion. Delta 1 of QA is what? That is okay DFA, right? Delta 1 of QA is what? Union of, we are taking the union of, for example, yeah, 1 2 on A in the sense 1 on A, 2 on A, union of them, right? You are taking. So delta 1 of QA is what? Union of R belongs to Q. You are taking the union on the transition table of this NFA, and the transition function of this NFA is denoted with what? That is a delta. Therefore, you have to use delta of. On this table, right, I have taken this delta of R A. Delta of RA. For example, if you take Q as okay 1 2, then R value becomes okay 1 2. You are taking RA in the sense what? 1A union, that is 2A. That is the reason we are writing this union. So you don't need this. Otherwise, I can put okay one more bracket. It is up to you. Union of this. Okay. So now if I am going to replace this 1 2 with okay single name like say 1 2 with 1 1 3, we can replace 1 2 with say 2, 1 3 with say 3, 1 4 with say 4. You are known what are the different states that what you have right in this diagram. So wherever this 1 2 is there, you just replace the 1 2 with 2. So by doing so, right, what we are going to get? State 1, no change with respect to that. Yeah, 1 on A, that is 1 2. 1 2 in the sense what? That is 2. You have to take for input symbol, that is A. Your known input symbols are A, B. So 1 on A is 1 2. 1 2 in the sense you can take it a single name, that is okay 2. 1 on B is 1 itself, right? Next, here you have 1 2. 1 2 in the sense you are known, that is a 2. I told you, right, in this table, wherever this 1, 2 is there, you just replace with 2. So in place of this 1, 2, you are supposed to take 2. In place of this 1, 3, you are supposed to take, that is, okay, 3. Wherever this 1, 3 is there, you just replace that 1, 3 with 3. Here also we have that is 1, 3. I'm just going to replace that 3. So here you have the entry as 1, 2. 1, 2 in the sense what? That is a 2. 1, 4 you have. 1, 4 in the sense what? You are replacing with a single digit. That is, okay, 4. And then 1, 4. 1, 4 on A. Wherever this 1, 4 is there, you are going to replace that 1, 4 with what? That is a 4. Yeah. So here you have 1, 4. Therefore, I have replaced with 4. Here you have 1, 2. I need to replace this 1, 2 with what? That is a 2. And what you have here, that is a 1. No change with respect to 1. That is like a single state itself. Right? So if there are more than one state, I have grouped them and labeled with a single name. Right? So this is the DFA, that it corresponds to this same NFA. That is, for DFA you are using, that is delta 1. Right? So this is for the transition table, that what you got here, that is DFA for the same example. For 1, 2, 1, you can verify the entries. So states are 1, 2, 3, 4. Inputs are A, B. You can, so in the column A you have only 2, and in the column first you can verify that. See, 1, 2, 3, 4. In the column A you have, that is 2, and in the column B, here you have, okay, 1, 3, 4, 1. Or do you have that same thing, 1, 3, 4, 1? So this is the DFA. This is how, right, you are going to make a conversion from NFA to DFA. So if you carefully watch, here the start state is denoted with Q1, and in this case here it is 1, that is with respect to DFA. And with respect to this NFA, your start state is what? That is Q0, and it is 1. That is same in the sense what? Q0 is equals to Q1. With respect to this NFA you have Q0. With respect to this DFA you have, that is Q1. From this, what you have understood? That is Q0 is Q1, right? And then you are known what states I have made as final states in the conversion process. No, not here. Yeah. I made this 1, 4 as a final state. 1, 4 corresponds to what? That is a 4. That is 4 is a final state that I have taken in the DFA, right? You have seen. So, you know, the final state of this NFA is A. The final states of this DFA I have denoted with what? That is A1. A1, right? So can you establish the relation between these two? That is A1 is, right, some state, right, say small q belongs to this set of states, say, okay, Q1, right? You are known this 1 is there in the Q1 such that what it says is Q, what states, right? What state that you are taken, intersection. The final state of this NFA is denoted with what? That is A, you are known, right? Q intersection A is not equals to pi, that is, it should not be empty. That state, you should treat it as what? Okay, final state. For example, here, I have taken this in the conversion process, I have taken this 1, 4 as a final state of this DFA. 1, 4 as a final state of this DFA. Why so? This is what it says, right? For Q belongs to Q1. Q you are known here, capital A is what? 4. Here, Q in the sense what? That is 1, 4. 1, 4 intersection 4 is equals to 4. It is not equals to pi, right? So that is the reason it says Q intersection A is not equals to pi. That is the reason this 1, 4 is taken as a final state of this DFA, and we are known this 1, 4 stands for what? That is okay 4. So with respect to this DFA, you have this 4 as a final state, right? With respect to this. So this is how you can make a conversion from NFA to DFA. Now we will try to problematically have seen, right, how to make a conversion from NFA to DFA. Now you recall what is the basic difference between this NFA DFA. In a transition table of this NFA, for a given state and input symbol, you will have multiple states. In DFA, you will have one and only one state. So that is the basic difference between this NFA and DFA. Now I'm going to prove that NFA and DFA, they both accept the same language. How do they act? You are known that they both accept the same language. Now we have to prove that they are going to accept the same language. So for X belongs to, say, sigma star, you know about, yeah, sigma star. We have to prove, I'm using delta 1 for, okay, that is DFA, delta 1 star of Q X is equals to, this is DFA, they both accept the same language. For NFA, you are using the transition symbol as, that is delta, right? So delta star of Q X. Already with an example we have seen how to make conversion, and we have cross-checked, do they both accept the same language or not? Yes, we concluded that they both accept the same language. Right, now consider this delta 1 star of Q X. Let this X is epsilon, let this X is epsilon, then you are going to get delta 1 star of Q epsilon. So with respect to this DFA, I have given delta 1 star of Q epsilon is what? That is okay, Q itself. So delta 1 star of Q epsilon, in the sense what here? That is Q itself. You are known for a DFA, used the subscript as 1. If you want to use that, you can use, it is up to you. That is delta 1. If I make this change, this becomes delta 1. This also becomes, Q1. Wherever Q is there, you just replace here with, that is Q1. So this, it becomes what? That is okay, Q1 itself. And with respect to this NFA, I have used the transition function name as delta, and there I have used, if I am correct, if you remember, for NFA, I have used what? That is the start state as okay, Q. Yeah. So any transition, it is going to starts with what? That is start state itself. So we have to prove this delta 1 star of Q1 X is equal to delta star of Q0 X. I started with delta 1 star of Q1 X. So I first letted X is equal to epsilon. So delta 1 star of Q1 epsilon is what? Q1. And in the conversion, you have seen the start state in both is same. That is the reason I have written here, that is in NFA your start state is 1, and also in DFA the start state, it is 1. So it is same, so we came to know that is Q naught is equals to Q1, right? So since Q naught is equals to Q1, I'm going to replace this, okay, Q1 with what? Q naught itself. Oh, I'm going down. Q naught. So this Q naught, this in turn can be written as, for I started with DFA, that is DFA transition function, that is delta 1 star. I supposed to prove this. Delta 1 star of Q1x is equals to delta star of Q naught x. So I can rewrite this as what? For NFA, you are known, that is delta, right? So delta star of Q naught on epsilon. We came to know that whether it is DFA or NFA, delta star of Q on epsilon is, that is Q itself. Therefore, I can, but we have lettered this epsilon as x, right? That is x is equals to epsilon. Therefore, if I'm going to replace this epsilon with x, I'm going to get x. So from this delta 1 star of Q1 x, I got this delta star of Q naught x. Hence the theorem, I can say. So this is how, right, you can prove NFA and DFA, they both accept the same language. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.